Hi, pre-algebra. Today we are looking at lesson 7.2, understanding the distance formula, and we are going to divide this lesson into two parts. The first part is looking at shapes or triangles on a coordinate grid and using the Pythagorean theorem to help us understand the distance formula. We're going to get to the distance formula tomorrow, but today we are going to just see how it works on a coordinate grid. We're laying the groundwork, we shall say. Today's assignment, we are only going to look at 1 through 6, but number 2, I want you to save it for later. We are not going to touch number 2 today. We're going to touch it on our next one. So let's get started. We are going to look at number 3 on page 9, and I'm going to make it a little bit closer. And it says, Samantha plots the points P, -3 and 4, Q, 3 and 3, and R, 4 and -3 on a coordinate plane. She joins the 3 points to form a triangle, PQR. Is the triangle a right triangle? Explain. In geometry, it is not enough to look at it and say no or yes, it looks like a right triangle or it does not. We're going to have to prove it. And how we can prove whether a triangle is right is by using the Pythagorean theorem. So what we are going to do is make a right triangle out of each of these. So let's look at PQ. PQ goes across a diagonal. It forms a diagonal. And the thing about PQ is, unless we get out a ruler, we cannot know how long this is. But what we can do is make a right triangle out of it. I'm going to highlight this one and this one. So highlight, we are connecting the two points. And when we connect them in this way, it makes a right triangle. Okay? It is pretty easy to figure out the lengths of our two legs on a coordinate grid because each of these we can see stands for 1. So the length from here to here of this leg is 1, 2, 3, 4, 5, 6. So this is 6. And then the length here is 1. Okay, and this is our x. This is what we're trying to find. And this is our hypotenuse. So since we have the legs, we can put that in and figure out what the hypotenuse is. Remember, Pythagorean theorem, a squared plus b squared equals c squared. A and b are legs, c is your hypotenuse. Well, let's put in, this is for PQ. PQ is one of the legs is 6, one is 1. So 6 squared plus 1 squared equals c squared. Okay. Now remember, I'm going to skip a step that we've done before. Not really skip a step, but we don't want c squared. We want c. So to unsquare it, we're going to find the square root. But we're going to find the square root here too. And the reason I did that is we can put this in our calculator in 1 step instead of 2. So we're going to get our calculator. Hopefully you can see it. I'm not sure how bright or dark it is. So we are going to get our square root sign, and we're going to put 6 squared plus 1 squared and push enter. Oops, I've got it in square root form and math print form. So let me turn it to a decimal, and it is 6.08. We are going to round our answer to the nearest tenth. The 0 becomes a 1, so it is 6.1 units. So C is 6.1. Now let's look and find the length of this leg of the triangle. Again, I'm going to connect the dots using our grid lines to make a right triangle. Oops. Okay. And the length of this leg is also 1. The length of this leg is 1, 2, 3, 4, 5, 6. It's also 6. All right. So since this is 6 by 1 and this is 6 by 1, we already found it. So that is QR is also 6.1. Okay. Now we need to find the length of this side. And again, I'm going to go down and across. And we need to find the length of the two legs. So looking at this one, 1, 2, 3, 4, 5, 6, 7. And this is PR. Write that down, PR equals, this is 7. And this side is 1, 2, 3, 4, 5, 6, also 7. All right, so we've got 7 squared plus 7 squared equals, again, the hypotenuse is c squared. I don't want to know what c squared is, I want to know what c is. So I'm going to find the square root of both. So c is, clear that, get the square root of 7 squared plus 7 squared equals 9.89. We're going to round that up to 9.9. C is 9.9. Okay, so now I know the length of this is 6.1, the length of this is 6.1, and the length of this is 9.9. We can put these in the Pythagorean theorem to prove whether or not this is a right triangle. So leg, hypotenuse. 6.1 squared plus 6.1 squared equals 9.9 squared. Okay, move this up a little. So 6.1 squared plus 6.1 squared equals 74.42. Hear that? 9.9 squared equals 98.01. You can see that these are not equal, so it is not a right triangle. All right, what I need you to do is on number 1, you're going to find the distance from here to here, okay? And again, you're going to make a right triangle out of it like we did here and count how long these legs are and then put them in the Pythagorean theorem to figure out the distance from here to here. Skip number 2, we're saving it for tomorrow. We did number 3 together, and I want you to try number 4, as 4, 5, and 6. So that's what I want you to do today. Have a great day, and I will see you hopefully soon. Have a great one. All right, I'm recording. No, I'm done. I was recording the whole time. Well, okay, I was making a video, but anyway. Let's see, I need to end the meeting. How to do that?